So in your book, you are going to write out, be able to calculate the surface area of prisms. Okay? No, in front of you, but this is next. So we've done area and perimeter of two-dimensional shapes, and we need that to move on to this one. Okay? And then we will, after this, we'll do the volume of prisms. I guess first of all, though, we need to define what a prism is. Does anyone know? Desmond?
It's a 3D shape that...
Okay, I'll write that down. So we've got a three-dimensional, I won't call it a shape, because that would be 2 dimensions. Three-dimensional, the word is object. Three-dimensional object.
That has the same... No. That every side is the same shape.
No, that would not be a prism, actually.
What's that? Cube. No,
Well,
what about
it could be a tetrahedron.
Yeah.
Remember we did polyhedra? Yeah? Tetrahedrons, icosahedrons. Do you remember the Greek, what were they called? No, the shapes the Greeks identified. They were a certain type of shape. No, they were, well, yes, they were the only shapes that could be used for dice.
Oh, the video that you showed us.
Does anyone remember the name? Named after a very famous mathematician?
Albert Einstein.
No.
Me.
No.
I'm sorry.
Azra, I'll say it again. Please do not take what someone else has said in an attempt to answer my question and just criticise it. If you want to give me your answer, fine. Other people have had a go. If you don't agree, Jake. I said so we're talking about a three-dimensional object, and Desmond had a go at defining a prism as saying a three-dimensional object where every side was the same shape. And I said it's not that; those would not be prisms. But I did say, do we remember what those were called? And I took your attention back, and yes, Jasmine said we did watch a video. They were very important to the Greeks, so they're named after a Greek mathematician. Okay. And they were important because they're the only shapes that can be, only objects that can be made from the same shape repeated, and therefore can be used for dice. That was a guy, but no, it's not. His name wasn't Plato. Yeah.
Oh,
They were the Platonic solids. Yeah. Do you remember the Platonic solids?
Oh, we had like a small unit.
Yeah, so guys, this one, a tetrahedron, is a Platonic solid. It is not, and I need to finish this off, I'm going to do it before the end of the year, bigger. I'm going to have like 4 of those all stacked up. So a Platonic solid is one where all the sides are the same. They are not prisms. How do I spell Platonic? So, named after Plato. So they were Platonic solids. So they are not prisms. So then the Platonic solids are the ones where all the sides are the same. So a prism is a three-dimensional object.
Isn't it like a pyramid?
A pyramid is also not a prism. Yeah. I can show you a prism. Sort of, roughly. It's slightly different to a prism. That's a prism.
That's
Also called a cylinder. But a cylinder is a type of prism. This is a prism, and it's called a... Well, it is a rectangular prism, but it has another special name. It is a It's not a cube because it's not a cube.
Rectangular.
It is a
Rectangle.
cuboid. Okay. Does anyone like chocolate?
Yes.
There is a chocolate bar, very famous one that comes in a specific prism. A Toblerone.
Isn't that a pyramid though?
No. Because a pyramid is
Triangular.
to a point. Yes, so a Toblerone is a triangular prism.
That's
Okay?
what I meant.
A cylinder is a circular prism. A cuboid is a rectangular prism. This is not a prism
Yeah.
It's not
Because it has a
Top?
because it's no. It's which is the bit that makes this not a prism?
Like the top part right there.
The top, because it changes. It changes here. If I were to cut it there, now it's a. If I took only that bit, that would be considered a prism and a cylinder. Okay? This is a prism.
No, because it gets from
It
there.
gets wider, so my cup is not. Okay?
And it's not closed.
So the definition of a prism is it has a what we call a constant cross section. Okay?
Constant.
A constant cross section. Now normally then a prism is made up of one two-dimensional shape
And then
and a lot of rectangles.
wait.
And that's what, so the other words then are surface area. So what's a surface area?
The top, the edges, the round,
Wait.
Jack?
The surrounding area was
Yeah.
outside.
The outside area. The area of all the faces. Good. So, even a cylinder is made up of two circles and a rectangle. I'll show you that if you don't believe me. So, let's try and draw some prisms. Now, you're going to use a ruler. Okay? You'll need a ruler. I did tell you not to rely on the ones on Mr. Cunningham's desk because he's taken those with him. So let's try and draw some prisms.
Wait, that's pretty good.
Desmond, why are you now recording? The constant cross section is, if I were to take that, imagine like it is like a slab of butter or something. If I were to cut it halfway through, all right, what shape would I see? Another one of the same of what's on the end. So that's what it's called, a cross section. So if I cut across it, I get a constant shape. So everywhere through this shape is always the same, not similar, the same rectangle. Okay? So I haven't drawn that very well, so what that should do, let me redraw that one. There you go. So if I draw, you can see that anywhere along this shape, so a cuboid, if I cut it, it's got a constant cross section. So like you saw with the other shapes we were looking at, it doesn't get narrower and that thing. So does anyone know what like the movie Bar of Gold looks like? Yeah, you've seen it? Is a typical bar of gold a prism?
Yes.
No.
Why not? Because it slants at the edges, yeah? So it slants either side, which is fine, but because the ends also slant in, the reason why they have that, by the way, you make ice cubes, and in ice cube trays, the solid ones, they're always a bit narrower at the bottom so that the ice cubes can slide out. So when they cast a bar of gold, they pour the molten gold into a cast, let it solidify, and then they can pull it out, which is why it has to be narrow at one end. If it was a cuboid, it would be hard to pull it out. Okay, so there's my cuboid. So do you understand it's got the same cross section? Can you see that I could do that from actually any direction?
Yeah.
Yeah. Okay, so a cuboid is a special one. All right?
Just triangle.
Like I say, it doesn't need to be amazing. Okay? The trick is to make sure a lot of your lines are parallel if they start coming together. Okay? Now it is important that you have it that it must be a constant cross section. I don't want you thinking things that are not parallel are still prisms. What I'll do, by the way, is it's good to practice, but I'll give you another sheet with it printed out, or I can print this out afterwards for you. So you've got, if you're struggling to draw it, don't worry too much. So what you have to do is, so for instance, I would now draw a line here and across and down, and that would be your cross section. Yeah? Right, my next one that I want to draw, I'm not going to draw a Toblerone because a Toblerone is a typical type of triangle. What's the triangle on the end of a Toblerone bar? The box, anyway. What type of triangle? It could be equilateral, but actually it's probably more like an isosceles. Now, do you notice I say the Toblerone box is the prism? The Toblerone bar, they have edges in, so it's not the bar itself, it's only the box. So what I've drawn is another triangle. Now again, I've done it like the cuboid, so it's on one side. So I'm then going to just extend it there and there, and I'm trying to make it parallel to that side. Okay, so this is going to be a triangular prism. Now for this one, it doesn't really matter what your triangle is. All right, just draw a triangle and then extend it. Now then the idea is so you'll notice I do my dotted lines to show hidden lines. So I'm going to do that. So that's hidden. I'm making sure all my lines are parallel. All right. So you can see how this triangle at the end is the same as that triangle at the other end, and if I were to chop this anywhere through, I would have the same shape. So it's a constant triangle. So a triangular prism only works in one direction, right? Or in one axis, it goes straight through. A cuboid could work in the three possible dimensions, but with the triangular one it only works in one way. Because if I were to try and cut it another way, I would get a different shape, wouldn't I? What would happen? What shape would I get if I were to chop it like along its length? What shape would the cross section be? It wouldn't be another triangle. It would be a rectangle, wouldn't it? Don't draw this, but let me just show you what I mean, what I'm talking about. If I were to cut this, like if I were to cut my knife like that and chop down, I would see a rectangle. And by the way, the reason why I can kind of see this is when I was young, I used to do a lot of this kind of drawing, and when I did my engineering degree, I did a lot of this kind of technical drawing. So I find it very easy to visualize all this in 3 dimensions. I look at that. I do appreciate some people find that very, very difficult, and they just see a mess of lines, right? It just takes a bit of practice. So when I was not paying attention to my teachers, I was drawing 3-dimensional objects because that's what I did to doodle. So anyway, No, I was just showing you that if you cut it in a different direction, it would not be a triangle. So it would be a rectangle. All right. So we've got a rectangular prism now. The triangle prism. The triangle could be any type of triangle. All right. So that could change, couldn't it? All right. We could have sort of a bar of gold, but not quite. It would be a
Trapezoid.
yeah.
I said that first. Trapezoid.
Trapezoid, trapezium.
Yeah, because it's the D. We already know it's a trapezoid. So it's a trapezoid. That's the 3D version. Trapeziangular prism.
Okay, so I've got. Don't really know.
Trapeziangular, right?
Trapezium
Angular.
based prism. If I would say rectangular based pyramid, or that's just what I would say. So it's a bit wonky looking, but then to be honest, it is a trapezium. And what I should, of course, have is this side should be parallel to that one, which I don't think mine is very well. But again, just to show, we should have a constant cross section. So if I draw like that, so my hidden lines, if I were to draw across and up, trying to keep things parallel. I'm just making like that line has to be parallel to that one, and that one has to be parallel to that one. So cross section, constant cross section, and the cross section is a trapezium. Okay? And of course, we should draw. Can you see how we can make prisms out of any shape? The new Smarties tubes. So when I grew up, Smarties were always in cylinders. They're no longer in cylinders. Now they're an octagonal prism. Yeah? But what we'll do is we should, of course, draw a cylinder. Now I'm going to draw my. Don't forget, I'm still recording. Just to let you know, just in case you forget. So I'm going to draw my same circle, and cylinders are hard to draw. So I'm going to draw and then I'm just going to draw from the top to the top. Looks a bit funny.
Nah, mine looks.
Maybe there's the cross section. I should redraw. Redraw my lines. Okay, so difficult, I know, to draw that one. But you can see the cross section, the constant cross section is supposed to be a circle, looks more like an oval, but you get the idea. So this is a cylinder, which is another prism. All right, so what we need to do then, if we're going to work out the surface area of a prism, what do we have to do?
Length times width.
It's not length times width times height, because that would only give you the volume of a cuboid. And I'm not after volume. So do you remember I said a prism, these two are the best ones really. Prisms are basically a shape that's extended. So you've got one shape at either end, and then you have lots of... Nope. What's the surface area? lots of rectangles. And what does it look like if I flatten a shape? What's it called? A net. So actually what we're looking at is we're looking at how much space do all the faces look like, and the way to do it is we think, let's flatten this shape into 2 dimensions, because area is 2 dimensions, therefore we're looking at nets of shapes.
Wouldn't it make the net of a shape? Because you said shapes are 2D, so it'd be 3D, so it'd be an object, and then it's object.
Yeah, sorry, you're right. The net of the object turns it into 2D shapes. Right? So for instance, let's have a look at what would a triangular prism look like as a net? Right? Yeah.
Well, it would be 3 rectangles, and then 1 triangle on the end of the middle one on both ends.
Yeah. So let's say here's my triangle. Now this is not a 3-dimensional version of it. All right. That is the triangle that has been folded down. All right. Then what I'm going to do is I'm going to draw the line. So maybe you want to wait until I finish this before you draw it. I'm then going to extend it. So this was what my prism. This is the extension. So you can see that it's the rectangle. And then I have exactly the same shape on the other end. That's as close as I can get. All right. So the cross section would have been those 2 triangles, yeah? But then what happens? So we need another rectangle that is the same length as that one. So I would have, I'm going to draw that there. And another one on the length there.
So it's not 3 triangles. This is 3 triangles. It's only 2 triangles.
So let's just say that maybe I should do these in different colours. So actually this line here, right, those 2 lines, if I folded it up, would match with this line. They would be together exactly. And then
So the bottom one and the top.
different colour.
And then the other one would kind of just be black.
And then this line here
Match.
would match with these ones. Oh, yeah.
We would need another rectangle, smaller rectangle.
And it would look black.
Why would I need another one, Jay?
Because
No, you would.
goes up.
But this here is already there, no? This one folds up there and this one folds across. Okay? Yeah.
I would agree that the rectangles are actually like on the inside of the triangle. But that ensures that when you're drawing it, it's more accurately.
Only if I feel that I can't measure correctly. But there are different ways to do it. The net of my shape. Now, originally, I was thinking I might actually put this one up here, and then they fold up. But I didn't leave myself enough room. But I still know that I can still make my net like that. So this is my net. Yeah.
Oh, also
Yeah.
the bottom one, like the bottom, matches up with the top.
Yeah. Okay. So we can put that in, can't we? That so this side here would match with this one, wouldn't it?
Yeah.
So if we label our triangle A, B, C lengths, right? This would match with B, this would match with C, A's already matched with A, okay? So we have rectangles. Now, this here would be the length of the prism. Okay? Do we see it? So let me just take you back up to here. All right, slightly different shape, but can you see how, if this was A, B, and C, okay, can you see how it all kind of folds up together? So imagine this end and this end kind of flapping down and lying flat, and then laying all the other rectangles out.
Oh, I see that. And then so the okay, yeah, I see that.
Yeah.
So watch it goes over.
Okay, I'm going to ask you to do something for me now. All right. I want you to, for tomorrow, I want you to bring in a prism that you can fold out flat. Just, no, I just want you to find one. Yeah, but don't bring your pencil case.
Because you have to cut it.
You have to cut. You might not be able to find a cylinder that you can cut. A cylinder is a very interesting one, but I've got cylinders. But if you can find, if any of you have a Toblerone box, bring one in, especially if it's a big one. If it's a small one, fine. If any of you have a tube of Smarties, especially if it's not a cylinder, bring it in.
I have like.
Everyone has a box.
What about like a square juice box?
Yep.
Like a cuboid.
Yep, cuboid. Bring anything in, but everyone must have one.
I will bring some extra. Why not?
But you know the deal, you've got videos to catch up. Is that clear? It's your homework. But if you can find anything more interesting